We're going to solve the system dx dt equals 2x minus y, dy dt equals 3x minus 2y plus 4t. Written in the form that we've been looking at, this is x prime equals 2, negative 1, 3, negative 2, x plus 0, 4t. Finding the determinant of 2 minus lambda, negative 1, 3, negative 2 minus lambda, and setting it equal to 0 results in lambda values that are 1 and negative 1. And that's going to give us eigenvectors of 1, 1, and for k1, and k2 is 1, 3. So we have that x sub c, the complementary solution, is c1 times 1, 1 e to the t plus c2 times 1, 3 e to the t. We're now going to express this in a form so that we can identify the fundamental matrix. So x sub c is equal to, I'll give you the step-by-step so we can follow along here, e to the t times c1 plus e to the, oh, that's negative t, my bad, e to the negative t, 3e to the negative t times c2. And because of the way matrix multiplication works, this can be expressed as e to the t, e to the negative t for the first row, and e to the t, 3e to the negative t for the second row, times the column vector c1, c2. Multiply it out, you'll see that it works out. And as a shortcut then, we can recognize that 1, 1 times e to the t is the first column of the fundamental matrix, and 1, 3 times e to the negative t is the second column of the fundamental matrix. Phi, then, the fundamental matrix, is e to the t, e to the negative t, e to the t, negative 3e to the negative t. Now, we need phi inverse. As a quick aside, if A is equal to the 2 by 2 matrix A, B, C, D, then there's a formula that I'm going to encourage you to memorize. And it's that A inverse is equal to 1 over AD minus BC. You might recognize that as the determinant of A. And then the entries in the upper left and the lower right switch places. And the entries in the upper right and the lower left change signs. So the inverse of the 2 by 2 matrix is 1 over AD minus BC times the matrix D, negative B, negative C, A. In the 3 by 3 case, it's of course more involved, and we can talk about that at another time. Here, we're going to find phi inverse, and we're going to multiply AD minus BC. So we've got that phi is equal to the matrix e to the t, e to the negative t, e to the t, 3e to the negative t. For the formula that we just looked at, this complicated beast, we need phi inverse. So I'll just quickly show you how to find the inverse of a 2 by 2 matrix, or one way to do it. Suppose A is the matrix A, B, C, D. Then there's a formula for in the 2 by 2 case. A inverse is equal to 1 over AD minus BC times, you may recognize that as the determinant of A, times a matrix where we take A and the upper left and lower right entries, we change places. And in the upper right and lower left, those entries, we change their signs. So for A equals ABCD, A inverse is 1 over AD minus BC times the matrix D, negative B, negative C, A. In the case of our phi inverse is equal to, we got e to the t times 3e to the negative t. That's going to give us 3 minus e to the t times e to the negative t, 1. So 3 minus 1. 1 over 2 then is what we get for 1 over AD minus BC. Now, 3e to the negative t and e to the t switch places, the upper left and lower right. And then on e to the negative t in the upper right and e to the t in the lower left, those change signs. So phi inverse is 3/2 e to the negative t, negative 1/2 e to the negative t, negative 1/2 e to the t, and 1/2 e to the t. If you're not sure about that, you can multiply phi inverse by phi and show yourself that you get the identity matrix. The integral was phi inverse times f of t, if you will, dt. So we're going to have here the integral of, I think it would be better if we took all these 1/2s and just pulled them out front. So I'm going to pull the 1/2 out front. And then the matrix that we have is e to the negative t, e to the negative t, that's negative. And then negative e to the t and e to the t. Oh, there should be a 3 there. And we're going to multiply it by f. F is the column vector 0 for t. We're going to integrate that after we multiply it with respect to t. This is going to give us 1/2. Now, remember how we multiply matrices, right? So 3 times 0 plus negative 1, well, negative e to the negative t times 4t. That's going to give us negative 4t e to the negative t. Negative e to the t times 0, e to the t times 4t, 4t e to the t. All of that's going into an integral, I'll put the 1/2 out front, times dt. And as I said, we're going to integrate these entry by entry. They both require integration by parts. I'll spare you the details, and this whole thing turns out to be 2t e to the negative t plus 2e to the negative t, 2t e to the t minus 2e to the t. Technically, we should have plus some constant here, but we actually don't need it, and I'll show you why in just a minute. X sub p, is equal to phi times the integral of phi inverse f dt. I recommend that you keep writing it out the way I'm writing it out. That is, I know I need phi, I know I need phi inverse. I'm going to multiply that by f and put it into the integral. Write it down. It'll help reinforce the formula. xp is phi times that integral. Write it down. From before, phi was this e to the t, e to the negative t, e to the t, 3e to the negative t, and we're going to multiply that by what we just found, 2t e to the negative t plus 2e to the negative t, 2t e to the t minus 2e to the t. Remember, that's a column vector, right? That's one entry in the top and one entry in the bottom. Notice if we had kept the plus c, what we would end up doing is multiplying phi times c, just reproducing what we already have in x sub c. That's why we don't need that constant. Multiplying these matrices together, as before, we're going to multiply e to the t times the top entry, and then e to the negative t times the bottom entry, and add together the results. We end up with 2t, the e to the t's divide out, plus 2. And then when we multiply that e to the negative t by the entries in the bottom, again, the e to the t's divide out, and we have plus 2t minus 2. Switching to the bottom row times that column vector there, again, you'll notice that all of the e to the t's are going to divide out. It's kind of a lovely result this time. Don't always count on that. But we have 2t plus 2 plus 6t minus 6. Got a little lost there. And the expressions simplify here. We end up with 4t in the top position, or the first entry, and 8t minus 4 as the second entry. Putting everything together, we have x is equal to x sub c plus x sub p. X sub c was that c1 e to the t plus c2 e to the negative t. And then xp that we just found, we can write it as 8 times t, that column vector 8 times t, plus the column vector 0, negative 4. And that's one way to write down the solution. I suppose another, if you really wanted to, would be to say e to the t, e to the negative t, e to the t, 3e to the negative t times c plus, maybe you'd write it as 4t, and then 8t minus 4. Take your pick.